Hello, this is Mr. Collier, and today we're going to get a rule and justify it algebraically. So let's take a look at this pattern. This is the sum of the first n consecutive odd numbers starting with 1, right? So obviously the pattern goes 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So always the number of odd numbers squared. Okay, there's 5 numbers here, and this is 5 squared. Okay, so the way to justify that is, well, you can write a list, write your list, 1, 3, 5, there's many in between, 7, 9, 11, so forth, and keep going until you have n odd numbers, okay, and that equals n squared. So the rule is, if you add up n consecutive odd numbers, you get n squared. In order to justify the rule algebraically, you need to actually figure out a rule for the last term, right? The last terms in these sums are 1, 3, 5, 7, 9. Okay? So if you've got 5 consecutive odd numbers, the last term is 9. So you can make a mini rule for that. Okay, if you have one number, the last number in the sequence is 1. If you have two numbers, it's going to be 3, 3, 5, 4, 7, 5, 9. Those are the last numbers, 1, 3, 5, 7, 9. These are going up by 2 each time, so this is just a linear rule. It is 2n minus 1, so the last number is always 2n minus 1. So we can stick a 2n minus 1 here in our formula, right? This is how you represent the sum of the first n odd numbers. To justify, we will write out that list and then pair certain sums together. So I've written the first 3 terms here. The last 3 terms, since they're going up in 2's, are going to be 2n minus 5, 2n minus 3, and 2n minus 1. And to add them together smartly, we take the first one and add the second one, and that gives you 2n. So whenever you have numbers going up by the same amount each time, you can always do this pairing method to easily count them. So 3 plus 2n minus 3 is 2n. 5 plus 2n minus 5 is 2n. You get a bunch of 2n's even with the previous ones that we can't see in the dot, dot, dot. So you get many 2n's. You get 2n times the number of pairs, basically, is the total sum, right? And the number of pairs, remember there's n odd numbers, so the number of pairs is actually n divided by 2. Okay, there's n numbers and we pair them up, there's going to be n minus 2 pairs, sorry, n over 2 pairs. Simply multiply those together and you get n squared, so this justifies your rule. We started with the rule listed here in terms of n, or the left-hand side of the rule. Pair them up, multiply it, and you get n squared, so you always get n squared. And that proves that your rule is correct.